So we'll start from rotary intersection. So basically, rotary intersections or roundabout, it is also called roundabout because you need to go in a round space whenever you try to negotiate a rotary intersection like this round section. Okay, there would be a large central island in the rotary intersection. That's why it is called rotary intersection or roundabout. A special form of at-grade intersection. Why it is at-grade intersection? Because all the intersecting roads meet at a same level, laid out for the movement of traffic in one direction around a central traffic island. Now, essentially, all the major conflicts at an intersection, namely the collision between throw and right turn movements, are converted into milder conflicts like marching and diverging. So, all types of crossing conflicts are converted into marching conflict or diverging conflict. Therefore, the severity of the accident would be reduced and severity of the risk, okay, it would also be reduced in case of rotary intersection. Now the vehicles entering the rotary are gently forced to move in a clockwise direction in a orderly fashion. They all these vehicles are have to move in a clockwise direction. Okay, then they wave out of the rotary to the desired direction. So suppose one rotary intersection is there. So all the vehicles which are coming in the rotary intersection, they have to move in this direction. Okay, they have to go in the clockwise direction. Okay, whenever they try to change their lane or change their route. Okay, so this is basically a rotary intersection. Now what are the advantages? This is very important. So advantages are traffic flow is required to only one direction of the movement, thus eliminating severe conflicts between crossing movements. Okay, so all the traffics which are moving in the rotary intersections, all the crossing conflicts are minimized, thus it will eliminate severe conflicts between the crossing movement, because there would not be any crossing movement. All the crossing movements will be converted into marching or diverging conflicts. All the vehicles entering the rotary are gently forced to reduce the speed and continue to move at a slower speed. Why slower speed? Because there is a large roundabout where they need to go in the clockwise direction, and in this way their speed would be reduced. Because of the lower speed of negotiation and elimination of severe conflict, and for this lower speed it will eliminate any number of severe conflict. Rotaries are self-governing and do not need practically any control by police or traffic signals. In the rotary intersections, all the traffic streams are regulated easily, and they do not need any external use of the traffic signals or traffic police. They are ideally suited for moderate traffic, especially with irregular geometry. Whenever the geometry of the intersecting roads are irregular, in that case rotary intersection is very much suitable. Now there are some disadvantages of the rotary intersection. So disadvantage is, even when there is relatively low traffic, in that case it is always predicted that the speed of the vehicle would be higher. But because of the rotary intersection, if there is considerably lesser number of the vehicle, in that case also all these vehicles are forced to reduce speed. Now, all the vehicles are forced to slow down and negotiate in the rotary intersection, therefore, the delay cost in the rotary intersection would be higher than the other type of intersection. Then rotaries require large area. Okay, the rotary intersection, if you want to build a rotary intersection, it is required a larger area than the other type of intersection, at-grade intersection, and in this way the cost of the rotary would be higher. And in some cases, because of the restriction in the acquirement of the space, the rotary intersection in some cases would be very much hard to build, generally in the city area or urban area. Now, next one is the vehicles do not usually stop at a rotary. They accelerate and exit the rotary at a relatively high speed. So, in the rotary, particularly rotary intersection, the vehicles are forced to reduce the speed. But whenever they try to overcome the rotary, then they acquire a higher speed. Okay, therefore they are not suitable when there is high pedestrian movement. So if there is high pedestrian movement, in such cases rotary intersection will fail. Now there are different guidelines for the rotary intersection. So guidelines are, first one is, rotaries are suitable when the traffic entering from all the four approaches are relatively equal. That is, all the intersecting roads should be major road. Okay, if major and minor roads are meet with each other, in that case rotary intersection is not suitable. Now there are some specification for the traffic volume up to which a rotary intersection can be accommodated, and that is a total volume of about 3000 vehicle per hour can be considered as the upper limit of the rotary intersection, and a volume of 500 vehicle per hour is the lower limit. So whenever the number of vehicle or volume of the vehicle increase from 500 vehicle per hour, in that case you can input some rotary intersection in the case of lane intersection. Okay, but suppose the vehicle, okay, or traffic volume increased beyond 3000 vehicle per hour, in that case rotary intersection will not be helpful. A rotary is very beneficial when the proportion of the right turn traffic is very high. You know, right turning vehicle will cause serious crossing conflict. So in such cases, if there is huge number of right turning vehicle, in that case a rotary intersection will be very much effective. And the percentage, that is the right turning vehicle, if the right turning vehicle is more than 30%, in that case you can go for the rotary intersection. So if you are given a task to find out whether you can build a rotary intersection in case of a plane intersection, in that case first you have to find out what is the traffic volume. Now suppose if the traffic volume over that area is more than 500 vehicles per hour, in that case you can go for the rotary intersection. Now if the right turning vehicles over there is more than 30%, in that case also you can go for the rotary intersection. Now rotaries are suitable when there are more than 4 approaches, or if there is no separate lanes available for the right turn traffic. In such cases also you can go for the rotary intersection, because in such case if you go for a plane intersection it will create some hazardous situation and there will be traffic conditions and conflict, area of the conflict would be higher. Then rotaries are ideally suited in the intersection geometry is complex. If the intersection geometry is complex, in that case rotary can be ideally suited over there. Now there are different design elements for the intersection design, rotary intersection design basically. So first one is design speed. You need to find out what are the speed of the vehicle in different approaches. Different approaches mean different roads which are meeting at the rotary intersection. Then radius at entry and exit. What are the radius at entry and exit? So these are the radius at the entry and exit. Okay, suppose this is the radius at entry and this is the radius of exit. So you need to find out what is the radius at the entry and exit. Then the shape of the central island or size of the central island, shape is not, because the shape is constant, that would be round shape, but the size of the central island will also affect the design elements of the rotary intersection. Then weaving length and width, that is weaving length, and this is the weaving length and this is the weaving width. Okay, this is weaving width, this is the weaving length, and these are the channelizing island in the rotary intersection. Okay, so these are the different elements of the rotary intersection. So this splitted island are nothing but the divisional island or channelizing island, and this is a large roundabout. Now coming to the design element, so first one is design speed. So all the vehicles are required to reduce their speed at a rotary, as we have discussed. Therefore, the design speed of a rotary will be much lower than the roads which have connected in the rotary intersection. Now, although it is possible to design the roundabout without much speed reduction, the geometry may lead to very large size, incurring huge cost of construction. As you increase the size of the rotary, in that case, the speed reduction would be minimum, but in such cases, you need a huge space and it will ultimately increase the cost of the construction. Then the normal practice is to keep the design speed as 30 to 40 km per hour for urban and rural areas as respectively in the rotary intersection. So it is your aim to design the rotary intersection in such a way so that the design speed at the rotary intersection should not exceed 30 km per hour in the urban area and 40 km per hour in the rural area. Next is entry, exit and island radius. What should be the entry, exit and island radius? Now the radius at the entry depends on various factors like design speed, super elevation and coefficient of friction. Okay, you know, if there is a curved path, in that case there will be some centrifugal force, so therefore super elevation has to be considered. And whenever you are considering the super elevation, in that case it will affect the rotary design. Now if you considering the super elevation, in that case coefficient of friction will also come, it will also affect the design of the rotary intersection, and design speed is also associated with the super elevation design. So therefore the radius at the entry will depend on the design speed, super elevation and coefficient of the friction. Now next is the entry to the rotary is not straight, but a small curvature is introduced. So therefore there is entry curve. Okay, therefore this entry curve or entry radius is mentioned. Now therefore for this reason this will force the driver to reduce the speed. You know, whenever you are driving your vehicle in the horizontal curve, generally you tend to reduce your speed. Okay, so similarly in the rotary intersection also, as there is an entry curve, for that reason you are forced to reduce your speed. Now the speed range of about 20 km per hour and 25 km per hour is ideal for urban and rural design respectively. So its maximum value is up to 30 km per hour for the urban area and up to 40 km per hour in the rural area. Now the exit radius should be higher than the entry radius and the radius of the rotary island, so that the vehicles will discharge from the rotary at a higher speed. So basically that is also disadvantage of the rotary, but you have to keep in mind, because there would be considerably delay in the rotary intersection when the vehicles are forced to reduce their speed. So whenever they are exiting the rotary, in such you have to design the exit curve in such a way that its radius is higher than the roundabout and higher than the entry curve, so that their speed is increased. A general practice is to keep the exit radius as 1.5 to 2 times of the entry radius. So whatever entry radius you have put, suppose your entry radius is 10 meter, in such cases your exit radius should be 20 meter, like that. However, if pedestrian movement is higher at the exit approach, then the exit radius could be set as same as that of the entry radius. Now, if the pedestrian movement is higher in a particular rotary intersection, in that case, you can put the entry and exit radius similar. Because if you put the exit radius smaller, then the 2 times as the entry radius, in that case, the speed of the vehicle will not increase. The radius of the central island is governed by design speed and the radius of the entry curve. As the vehicles are coming through the entry curve, therefore the design speed in the rotary intersection will be governed by the radius of the entry curve. Now, the radius of the central island in practice is given a slightly higher reading so that the movement of the traffic already in the rotary will have priority of the movement. Suppose some vehicles are moving in the rotary intersection, so if you increase the width of the island or radius of the island, central island, in that case they will be given preference for the movement so that they can easily exit the rotary intersection than the other vehicles which are just entering the intersection. Now, the radius of the central island, which is about 1.3 times that of the entry curve, is adequate for all practical purpose. So, first your task is to design the entry curve. After the entry curve, you can design the exit curve. You can make it as similar as an entry curve, or you can make it as a 1.5 times to 2 times of the entry curve. And for the radius of the central island, you can go as a 1.3 times of the entry curve radius. Then coming to the next portion, width of the rotary. Now the entry width and exit width of the rotary is governed by the traffic entering and leaving the intersection and the width of the approaching road. So in the entry and exit, therefore there would be approaches means that road connected with the rotary. So the width of the entry and exit would be governed by them, and the number of traffic which will be existed over there, or which you can expected to cross the rotary intersection. Now the width of the carriageway at entry and exit will be lower than the width of the carriageway at the approaches to enable reduction in the speed. This point we have already discussed. IRC, that is Indian Road Congress, suggests that a 2-lane road of 7 meter width should be kept as 7 meter for the urban roads and 6.5 meter for the rural roads. That is the width of the rotary. Then further, a 3-lane road of 10.5 meter is to be reduced to 7 meter and 7.5 meter respectively for the urban and rural roads. So what will happen if you increase by this? If you increase by this, in that case the area of the rotary would be very much high and it would be uneconomical. Now the width of the waving section should be higher than the width of the entry and exit. So whatever entry and exit is there, your waving width would be more than this. Then normally this width of the waving section is E1 plus E2 divided by 2 plus 3.5 meter, where E1 is width of the carriageway at the entry and E2 is width of the carriageway at the exit. So whenever you are designing the rotary, so based on the approach, we suppose the approach which is 7 meter, in that case your entry width would be 6.5 meter to 7 meter, and based on this you can design the waving width. Now, waving length determines how smoothly the traffic can march and diverge. As the waving length increases, so therefore the angle of approach would be minimum. But to increase the waving length, you need to increase the width, the radius of the central island. It is decided based on the many factors such as waving width, proportion of the waving traffic to the non-waving traffic, etc. So there are different design elements based on which a waving length or and waving width is decided. Now this can be best achieved by making the ratio of waving length to the waving width very high. If you make this very high, in that case the movement in the rotary intersection would be very much swift. Now a ratio of 4 is the minimum value suggested by the IRC. By Indian Road Congress, they have suggested the ratio of the waving length to the waving width should be 4. Now, very large waving length is also dangerous as it may encourage overspeeding, because if the waving length increases, this is the waving length, if the waving length increases, in that case the vehicle may acquire more speed in the rotary intersection, which may be disastrous in some cases. Now, next point is capacity of the rotary intersection. Capacity means how much vehicles the rotary intersection can accommodate swiftly without compromising different design elements like design speed, okay, traffic volume, etc. Now, the capacity of rotary is determined by the capacity of each waving section. Now, Transportation Research Lab TRL proposed the following empirical formula. So, this is the empirical formula by which the capacity of the rotary is find out. Okay, this is an empirical formula. Empirical formula means that formula is established based on the numerous practical problems. Now, here E is the average entry and exit width, that is E1 plus E2 by 2. W is the waving width. L is the length of the waving, that is waving length. And P is the proportion of waving traffic to the non-waving traffic. And as per the IRC recommendation, that proportion should be 4. So these are B and C. These are the waving traffic, and A and D are non-waving traffic. So this is basically waving traffic, and these two are non-waving traffic. If you want to find the ratio, in that case you can use this formula to find out the ratio. Now, what is the validity of this capacity formula? First one is waving width at the rotary is in between 6 and 18 meters. Suppose you have designed the rotary intersection. In that case, you have to validate your result using these values. So, first one is waving width at the rotary is in between 6 and 18 meters. It should be. Then ratio of average width of the carriageway at entry and exit to the waving width is in a range of 0.4 to 1. So if it is 0.4, in that case the width, the radius at the exit curve would be higher than the entry curve, and if it is 1, then the radius of the entry and exit curve would be similar. Now, the ratio of waving width to waving length of the roundabout is in between 0.1 to 0.4. Now, the proportion of waving traffic to non-waving traffic in the rotary is in the range of 0.4 to 1, and the waving length available at the intersection is in between 18 to 90 meter. So these are all the values which you have to validate after you design a rotary intersection. Is it clear, rotary intersection? Rotary intersection is clear? So suppose nobody is listening to the class, so I will proceed for the next class. So now we'll discuss about the parking facilities. You know, in the urban area, there is a huge problem of the parking, that how you park your vehicles in the market area or in the parking place also. You need to find out a suitable orientation, that how you park your vehicle. Okay, so parking is a major problem in the urban area. Now, there are two types of parking. One is on-street parking and another one is off-street parking or car parking. So, on-street parking means you are parked your vehicle beside the road section at a particular place. That is on-street parking. So, on-street parking means the vehicles are parked on the sides of the street itself. Now, this will be usually controlled by government agencies itself. They will provide some parking places along the side of the road. Now, common types of on-street parking are listed are listed below. Now, this classification is based on the angle in which the vehicles are parked with respect to the road alignment. So, if the vehicles are parked parallel to the road, in that case it is called parallel parking. Suppose this is the road and these are all the vehicles. In that case, if the vehicles are parked in this way, it is called parallel parking. Now, the vehicles are parked along the length of the road. Here, there is no backward movement involved while parking or unparking the vehicle. So, whenever you try to park your vehicle or unparking the vehicle, there is no backward movement. So, therefore, it will reduce the risk. However, it consumes the maximum curb length. Okay, it consumes a maximum curb length, means maximum footpath length or maximum length which is provided for the parking facility, and therefore only a minimum number of vehicles can be parked for a given curb length. Now, this method of parking produces least obstruction to the ongoing traffic on the road, since there is no backward movement associated with the vehicle, and vehicle can see the approaching traffic in the adjoining road, and they can easily merge with the traffic. Therefore, this type of car parking is the safest one, but it consumes a lot of places in the area. So this is the parallel parking. It is shown over there. Okay, the width of the parallel parking is required like 2.5 meter, and length will depend on the different vehicle sizes. Now, next one is 30-degree parking. So, in this type of parking, all the vehicles are parked in a 30-degree angle. Like in this figure, all these vehicles will be parked in such fashion. Now, in 30-degree parking, the vehicles are parked at 30 degree with respect to the road alignment. Now, in this case, more vehicles can be parked compared to the parallel parking, and also there is a better maneuverability because they are almost slightly changes from the parallel parking. Now, delay cost to the traffic is also minimum in this type of parking. So, this is a 30-degree parking. Okay, and this formula is for the space required for the 30-degree parking. This is not required for you. Now, next is 45-degree parking. So, in the 45-degree parking, you can adapt more vehicles, or you can park more vehicles than the 30-degree parking. But here, the maneuverability of the vehicles is further reduced, and risk associated with the 45-degree parking is also increased from the parallel parking and from the 30-degree parking. Now, coming to the next portion, it is 60-degree parking. In the 60-degree parking also, the maneuverability will further reduce from the 45-degree parking, and risk associated with it will also increase from the previous one. Then the last one is right angle parking or 90-degree parking. So in the right angle parking or 90-degree parking, the vehicles are parked perpendicular to the direction of the road. Although it consumes maximum width of the curve length required, but the length required is very lesser. Now in this type of parking, the vehicles need complex maneuvering, and this may cause severe accident, because whenever the vehicle try to merge in the traffic, first they need to go backward and then they can only merge to the traffic. Therefore, they will cause a disruption in the existing traffic. So this is all about on-road parking. Now another type of parking is there, off-street parking. And now this off-street parking, for this off-street parking, generally different parking lots are prepared, like the parking lots in some flats, okay, or in suppose in a mall there is underground parking space. So these type of parkings are called off-street parking. Now, in many urban centers, some areas are exclusively allotted for parking, which will be at some distance away from the main stream of traffic. Now, this type of parking is called off-street parking, and they may be operated by either public agencies or private firms. So, this is a typical illustration of the off-street parking. Okay, so in the off-street parking also there are different orientation like 30-degree, 60-degree, parallel, okay, 90-degree, etc. Now coming to the next portion, the requirement of the parking. So there are some minimum parking requirements for different types of building. For residential plot areas less than 300 square meters require only community parking space. Only for the community parking space in the residential area, the parking requirement is lesser than 300 square meter. For residential plot area from 500 to 1000 square meter, minimum 1/4 of the open area should be reserved for parking. Now, offices may require at least one space for every 70 square meter as the parking area. Suppose your area is 70 square meter office area, in that case you need one parking area. Suppose it is 140 square meter, in that case you need two parking area. Like that, for every 70 square meter of the area you need one parking space. Now one parking space is enough for 10 seats in a restaurant, whereas theaters and cinema halls need to keep only one parking space for 20 seats. So in the restaurant, if there are 100 seats, you need 10 parking places, and in the cinema hall, if there are 100 seats, you need 5 parking spots. So therefore, parking requirement for different areas would be different. Now there are different ill effect or adverse effect of the parking. So what are these? First one is congestion. So parking takes a considerable street space, leading to the lowering of the road capacity. You may have seen this in the Narengi area or any other busy marketplace area in the Guwahati, where because of the parking of the vehicle, the road section is hugely reduced. Next point is accidents. Now, careless maneuvering of parking. Suppose you are parking in an area and you didn't make any signs or any gestures. In such cases, sometimes some vehicles from your behind may conflict with you or may make some accident. Or suppose you are unparking from a parking spot. In such cases also, if you have to look very carefully whenever you are maneuvering, and a careless maneuvering may lead to some serious traffic accidents. Then environment pollution. Now, they also cause pollution to the environment because stopping and starting of the vehicles while parking and unparking results in noise and some fumes. And they also consume some fuel in due process, therefore increase the risk of the environmental pollution. Then obstruction to the firefighting operation. The parked vehicles may obstruct the movement of the firefighting vehicles if they are parked in a anonymous locations or the locations where they need not to park. Now, parking statistics. Now, before taking any measures for the betterment of the condition, you need the data regarding availability of the parking space, extent of its use, and parking demand in that area. Suppose you are doing a survey in a market area, so in such cases, you need some extensive data about all the parking facilities existing over there. If there is parking facilities, you need to find out whether the vehicles over there can be parked over there. Now demand is, suppose there are the parking space for 5 vehicles. Now you have observed there are already 10 vehicles over there, so here demand is very much high. So how you can overcome this situation? You need to find out through different data analysis. Now, based on the there are for each vehicle parked over there in the market area, there is some duration associated with it. Each vehicles will not park forever. They need some particular time. Suppose you are parking your vehicles in a market area, so whenever you finished your marketing, in that case you will leave that parking spot. So these situations or these cases you always need to remember whenever you are going for a parking analysis. Now there are different terms associated with that parking analysis or parking statistics. So first one is parking accumulation. So it is defined as the number of vehicles parked at a given instant of time. Suppose at 7 p.m. how many vehicles are parked over there? That is your parking accumulation. So parking accumulation will change time to time depending on the different condition. Then coming to the next point, parking volume. So parking volume is the total number of vehicles parked at a given duration of time. So in the parking accumulation, that is given instant of time, and parking volume is given duration of time. Given duration means suppose between 7 p.m. to 8 p.m. how many vehicles have parked over there. That is your parking volume. And parking accumulation is at particular 7 p.m. how many vehicles have parked over there. So basically that is the basic difference between the parking accumulation and parking volume. Next coming parking load. The parking load gives the area under the accumulation curve. So it can also be obtained by simply multiplying the number of vehicles occupying the parking area at each time interval with the time interval. Suppose from 7 to 8 am 5 numbers of vehicles placed over there. So you can find out what is the total parking load over that area during the entire duration of the time, and it is expressed as vehicle per hours. Then coming to the next portion, average parking duration. So it is the ratio of total vehicles hours to the number of vehicles parked. Suppose what is the total vehicle hours, that is a particular vehicle take for that parking divided by total parking volume. Then parking turnover, it is the ratio of parking volume to the number of bays available. Number of bays available means number of parking bays or number of parking space available over there. Then coming to the next portion, parking index. That parking index is parking load divided by parking capacity into 100. So whenever you are doing for the parking analysis, you have to go for the parking survey like volume survey. So there are different type of parking survey. So first one is in-out survey. So in the in-out survey, suppose a parking lot is there, so you will be placed over there and you will mark what are the number of vehicles which are parked over there at a particular time and what are the number of vehicles which are unparked from that particular location at a particular instant of time. That is called in-out survey. That is how many vehicles are in and how many vehicles are out from that particular parking lot. Now this is a numerical example. So from an in-out survey conducted for a parking area consisting of 40 bays, the initial count was found to be 25. Okay, so this table gives the results of the survey. So this is the different time interval. This is in and out number. That is 3 vehicles in for the parking and 2 vehicles out from that area. Okay, these are the in and out from different time instances. So from this you need to find out the accumulation, total parking load, average occupancy and efficiency of the parking load. So first one is time in out. Now accumulation is, you need to follow these formulas. What is the parking accumulation? Parked at a given instant of time. So at a given instant of time you need to find out what is the parking accumulation. Suppose for 5 minutes you have found out that the accumulation is 26 and there are different traffic accumulations over that area which you have to mark. Then you have to find out the occupancy and parking load using the formula provided over there, and in this way you can find out all the traffic statistics data. Okay, this is a numerical, you just go through it, this is not so important. So you just have to go with the formulas and you just put the values over there and you will get all this data. Then another important method is license plate method. So in the license plate method, what you have to do, it is like in-out survey, but you have to mark the license plate. Okay, so this results in the most accurate and realistic data. So in this case of survey, every parking stall is monitored at a continuous interval of 15 minutes or so, and the license plate number is noted down. So in every 15 minutes you will note down the license plate number of different vehicles, and from that time to time data you will find out that how many numbers have entered over here over the area and how many numbers of vehicles exist from that area. Now this will give the data regarding the duration for which a particular vehicle was using that parking bay. Now this will help in calculating the fare, because if you want to impose the fare, basically this parking fare will be based on the duration of the time you have parked over there. Suppose for 1 hour parking you can impose 20 rupees, for 2 hour you can impose 30 rupees or 40 rupees, like that. So for this reason you need to find out what is the average duration of time for which all these type of vehicles have parked over there. So this is all about the parking studies. I think it is clear to you.